Okay, so I'm going to be working through the review for Exam 2 for College Algebra. I'm going to be doing a couple problems more in depth, and then I'll get you started on some of the other ones so that you can finish the grunt work so this video is not excessively long. So, first of all, the first question is asking if the 0.72 or 30 are solutions to a system. So the system of equations is just two different equations. I'm just copying this off of your review so you can work the problem. This is just a plug it in type question. So is 7,2 or negative 30 a solution? Okay. Again, all you're doing is plugging things in at this point. So I'm going to take the 0.72 and I'm going to plug it into both equations. Okay. So the y is 2, the x is 7. So 2 equals 2 times 7 minus 12. Let me solve that. So it checks out in the first equation. Now I'm going to go ahead and do that in the second equation. Okay, so when you'll see me do that math, when I plug the x and the y in, I plug 2 in for x, for y and 7 in for x. When I do that, I get a statement that's true. Negative 3 does equal negative 3. So this 0.72 is a solution. So yes, 7,2 is a solution. We have to start over and do the exact same thing for the other point. So let's go ahead and move over. Y equals 2x minus 12. The y is 0. The x is negative 3. And I know you guys know that 0 does not equal negative 18, so this is automatically not a solution. Okay, so that's question number 1. Question number 2 is quite a different question where you're creating your own system. So the situation's the problem's a lot more different. So it says write a system of equations to solve the situation, then use a substitution or addition method to solve the equation. So he's talking about peanuts and a mixed nut mixture. Okay, our goal. So what we want to happen is a jar of peanuts that's 56% peanuts. Okay, that's our goal. Right now we have a jar of peanuts that's 45% peanuts. Okay, so we know that's wrong, so we know we need to add something to it, and the problem tells us that we have to add 100% peanuts to that. So we know we have a mixture that's 45%, we want to make it 56, and we have to add 100% peanuts to get that done. And at the end of the day, we want 20 total pounds. Okay, so we're going to let x equal the pounds of peanuts. We're going to let y equal the pounds of the 45% mixture. Okay? So I know that this x plus the y has to equal 20 pounds because I want a total of 20 pounds. So that's my first equation of the system. Okay? The second equation of the system, we had to figure out how we're going to make this work. So y'all know about percentages. When you take a percent to make it a fraction, we move the decimal place over 2 times, so that makes that 1. So we're going to have 1x, we're going to have 0.45y, and we're going to have a 56% mixture, and we need 20 pounds of it. Okay, so let's simplify that just a little bit so it's not quite as ugly. 1 times x is just x. 0.45y, and then I'm just going to use my calculator to do 0.56 times 20 to make that math easy. And I get 11.2. So that's my second equation in the system. So we've got two equations, and we're going to use some kind of method in order to make it, or we're going to solve this system. So I'm going to use substitution. So what I'm going to do is on this top equation, I'm going to get it equal to something. So I'm going to do x equals 20 minus y. That's telling me that x is 20 minus y. So I can put 20 minus y in for any other x and it be equivalent. Okay? So I'm going to use that, and I'm going to go into my second equation, and I know that x is 20 minus y. So I'm going to put in 20 minus y for x. I'm going to keep writing the rest of it out. And if you will notice, that makes there only one variable in this equation. I'm just down to only having y's. Okay? So now I'm going to simplify 20 minus y plus 0.45y equals 11.2. And then a negative 1y and a positive 0.45y gives us a negative, so 20 minus 0.55y equals 11.2. I'm going to have to bump up over here because I'm out of paper. So I'm going to get all the numbers on one side, so I'm going to subtract 20 from both sides. So 11.2 minus 20, that's negative 8.8. So I've got a negative 0.55y equals negative 8.8. Oops, sorry, I'm off the page. Okay, now to get y by itself, I'm just dividing by negative 0.55. So negative 8.8 divided by negative 0.55 is 16. So y equals 16. Now what is y? Back to up here. So that means y was the amount of the 45% mix. So to make this work, I'm going to have 16 pounds of the 45% mix. And I know from up here that x plus y must equal 20. So if y is 16, then x has to equal 4. So we're going to need 4 pounds of pure peanuts. Okay, so the question again is asking how many pounds of the pure peanuts. So it's looking for this answer right here. So 4 pounds would be our final answer. Alright, moving on. Question number 3. Solve each system by using substitution or addition if the system does not have a solution state, whether it is inconsistent or whether the system is dependent. Okay, so we are solving these systems. So I want you to treat each one of these 3 systems as completely separate because they have nothing to do with each other. Okay, they're just 3 different problems that she gave you example-wise. So the first one says x equals 5 minus 4y. The second one says negative 3x plus 7y equals 4. Okay? Now, she said you can use substitution or you can use addition. Guys, why would you add if you've already got one that's set up like a substitution? Because remember, substitution is where you have one variable by itself all organized on one side, and I can plug that in for x. So that first equation is telling me x equals 5 minus 4y. So I want to take what x equals and put it in for x in the other equation. So I'm going to show you how to do that. So I'm going to do negative 3 times 5 minus 4y, close your parentheses, plus 7y equals 4. Now I need to distribute. So negative 3 times 5 is negative 15. Negative 3 times negative 4y is positive 12y. Plus 7y equals 4. 12y plus 7y is 19y, so I have negative 15 plus 19y equals 4. going to get the numbers on one side, so I'm going to add 15 to both sides. 19y equals 19, and y then equals 1. Okay, that's only half of it because I only have the y. So now I need to plug in for what x equals. Well, guess what? My equation's already helping me with that. So x equals 5 minus 4y. X equals 5 minus 4 times 1, because you told me that y was 1. 5 minus 4, so x equals 1 also. So when you're answering these questions on your exam, you're going to give the answer as an ordered pair, just like x, y. So your solution is the 0.11. Okay, let's go to the second system. So let me try to make columns here so I can fit them all. Alright, so the second equation system says 0.2x equals 0.35y minus 2.5. Second equation, 0.16x plus 0.5y equals 5.8. Okay, this is a very similar type of problem. It looks close to that substitution, right? Because it's almost x by itself, but we got this gnarly little 0.2 in the way. So how could I get rid of 0.2? So what I would like to do is I would like to go through, if it's multiplied to the x, we're going to get rid of it by dividing. So I'd like to take that first equation and go through and divide everything by 0.2. Okay, what that does is it cancels out that coefficient in front of the x, so I get x equals, then just use your calculator, lean on your calculator, 0.35 divided by 0.2 gives you 1.75, then negative 2.5 divided by 0.2 negative 12.5. Okay, this is not the only way to do this. There's a lot of different ways, but this is just how it looked right in my brain. So remember, now when we have something that tells us what x equals, I can go through and I can put that into what x is in the other equation. So this is going to be a little long. So 0.16 times x, which is 1.75y minus 12.5 plus 0.5y equals 5.8. Okay, so now we're going to distribute 0.16 times 1.75. That's 0.28, so 0.28y minus 12.5 times 0.16. 2 plus 0.5y equals 5.8. We're getting shorter. Now we can combine these two terms. There's two y terms. So you have 0.28y plus 0.5y. So you get 0.78y minus 2 equals 5.8. Well, y'all know that we can get the numbers on the same side, so we're going to add 2 to both sides. So I get 0.78y equals 7.8. To get y by itself, I divide both sides by 0.78. So 7.8 divided by 0.78 gives me 10. Y equals 10. Okay, remember that you're only halfway there because you still have to figure out what x equals. So now we need to plug back in to get what x equals. And you can do that in either equation, it does not matter. So just pick one of those original equations they gave you and let's plug back in. I'm going to pick the one up here where it tells me what x equals because I think that's the easiest and there's not as much algebra, but you can plug into any one and it's fine. So x equals 1.75 times y, which is 10, minus 12.5. Okay, so then use your calculator. X equals 17.5 minus 12.5. So and then x equals 5. Remember, we're giving our answers in ordered pairs, so x then y, so your answer is 5, 10. Okay. The third one, I can help you guys do. She's got a typo in that second equation. There needs to be an equal sign before the 3 halves. So I will show you how I would set it up, and then I'm going to let you guys work it for the sake of time. X equals, oh, nope, dang it, sorry. X minus 2/5 y equals 3 over 10. And then 5x minus 2y equals 3 over 2. Okay, I'm going to use addition here, and the reason why is I can multiply. I've got an x and a 5x, and to make those go away, if I can make this top equation have a negative 5 in front of that x, then they would cancel out if I was adding them together. So I'm going to take this top equation, I'm going to multiply the whole thing, you have to do it to the whole thing, by negative 5. And that gives me negative 5x plus 2y equals negative 5 times 3 over 10 is negative 15 over 10, which is negative, is that 1.5? Sorry. Okay, at that point, you can use the addition method and go ahead and add or subtract. If you would rather not do it this way, there's a million other ways to do it, but this is the easiest way. But let's check out what happens really quick. So when you are doing the addition method down the equation, 5x and then a negative 5x, those cancel out. 0x's anymore. Negative 2y and positive 2y, crap, that cancels out. So 0y as well. Okay, here, positive 1.5, negative 1.5, 0. So what I end up with is 0 equals 0. Is that true? Yes. 0 always is going to equal 0. If it's true, then there are infinite solutions, or many solutions. Okay? It doesn't always work out like this, where the x's and the y's will cancel, but in this example, that's how it works out. Okay, so we are on number 4 now. These are the matrix questions. Guys, this is a memorization thing. When she's asking you to tell her the determinant, it's something where you're just going to have to realize and remember how matrices work. So for a 2 by 2 matrix, it's going to look like this. A, B, C, D. Okay, the determinant is equal to A times D minus B times C. And that is just a memorizing thing. That's not something I know that you don't. It's just something you have to keep in your brain. So, I'm going to do one of these matrices and let you guys do the other. Matrix A. Matrix A is 3 and then negative 1/2, 2. Okay, I just got that off of your review. That's all. So, you're going to be, so the determinant of matrix A is going to be, remember, so you're going to have to remember the order. It's A times D, so it's the top left and the bottom right. 3 times 2 minus B times C, which is top right, bottom left. So, negative 1/2, 10. Okay. Now, that gives us 6 minus a negative 5. When you have 6 minus a negative, it becomes a positive. Determinant is 11. Okay? It is that easy, but it's just a memorization thing of remembering the different properties of the determinant. Now, if you'll notice, number 5 is not a 2 by 2 matrix. It's actually a 3 by 3, meaning it's 3 wide instead of 2. Those are solved a little bit differently. Now I'm going to work through this. I'm going to get a couple different colors of pens so you guys can see what I'm doing. Again, more of a memorization thing, less of a mathematic thing. So we're going to do the first matrix, and we're going to use the method of diagonals. So first let me write the matrix out for you. Matrix D, 9, 2, 7, 5, 0, -2, -1, 4, 0. Okay? The first thing you do when you're doing these is you rewrite the first two columns like it never happened. So, 9, 2, 7, 5, 0, -2, -1, 4, 0. Again, I'm rewriting the first two columns. 9, 2, 7, 5, 0, -2. Okay, that's how you get started at first. Now, here's what you have to do. You're going to take the diagonals and multiply them together going forward. So I'm going to use a pink marker to do that. So, here's my diagonal. 9, 0, 0, 5, 4, 7, -1, 2, -2. I'm going to write that step out. That's the first step. So 9 times 0 times 0 plus 5 times 4 times 7 plus -1 times 2 times -2. That's step 1. Okay? 9 times 0 times 0 is 0. 5 times 4 times 7 is 140. Use your calculator. Lean on that calculator. 2 times -1 times -2 is positive 4. 0 plus 140 plus 4 is 144. That's step 1. You're not done yet. Now we're going to do the opposite diagonal, and you're going to subtract that. Okay? So, here's the opposite diagonal. 7 times 0 times -1, -2 times 4 times 9, 0 times 2 times 5. Okay, so 7 times 0 times -1 minus 2 times 4 times 9 minus 0 times 2 times 5. Okay, 7 times 0 times -1 is -7 minus 2 times 4 times 9, 72, but it's minus a -2 because I didn't pay attention to my signs, I'm sorry. Minus a -72 minus, this is 0 because anything times 0 is 0. Okay, there's a little bit of signs here, so be careful. So this whole thing is minus 7 minus a -72. Okay, the 0 goes away. We don't pay attention to those. So minus 7, minus, subtracting a negative just like adding, plus 72. Okay, so you're going to take this 144 that you got in the first step, 144, use your calculator, 144 minus 7 plus 72. Alright, so I messed up. Where did I mess up? I messed up back up here because 7 times 0 times -1 is definitely 0. So, I just made a mistake. I am sorry. Okay, so 144 minus 0 plus 72 gives you 216. Not quite as fun of problem, but if you will just remember the diagonals, I know y'all learned method of minors too. If you like that method, go for it. I struggle to remember which numbers go where, so that's why I choose this method. So you can practice with matrix F, and the solutions to that will be posted. We're going to move on to number 6. Okay. Number 6 is Cramer's rule. Number 6 is probably the least fun question on the whole review, so if we get through number 6, we're doing good. Okay, so the point of Cramer's rule is we're going to use a matrix to solve a system. That's Cramer's rule in a nutshell. Okay, so here's what we have to do. Here's the system they gave us: 2x plus 10y equals 11. 3x minus 5y equals 6. I'm going to make this into a matrix. Ready? We're going to have an x column, a y column, and a c. Why did I use c? C is for constant. If any kind of plain number, that's what we're going to use. So the coefficient to x is 2. The coefficient to y is 10. The constant is 11 in that first equation. The coefficient in front of x is 3. The coefficient in front of y, negative 5. The constant is 6. It is that easy. Okay? Now, what we have to do first is we have to find the determinant. Now, we have been here before with finding that determinant. Okay? We don't have to, in the regular determinant, we don't have to find the determinant with the constant. So, to find out what x is, to solve it that way, x is always going to be equal to the determinant of x over the standard determinant. Okay, so I need to find two different determinants that I can divide those and get what actually x is so we can solve this system. Okay, so let's find that first determinant, this bottom one. Okay, determinant is just with the x's and the y's. So 2, 10, 3, negative 5. Do y'all remember earlier when we were finding the determinant, we had to do something and we had to figure out how to get that done. We had to memorize which way the order was. Remember, it's like, the determinant was a times d minus b times c. Sorry, I'm running out of space. Okay, that means I'm going to multiply the number in the a position, which is 2, times the number in the in the d position, which is negative 5, so 2, negative 5, minus the number in the b position, which is 10, times the number in the c position, which is 3. Okay, negative 10 minus 30 equals negative 40. So that's our first determinant. That's this bottom number we're going to solve for x. Now let's find dx. dx is the determinant when it's the constant and the other number, and the other variable. So dx, I'm going to have to make a new matrix, and it's going to be the constant and y, because that's the other one we haven't used. We're finding dx, so we're going to use c and y. So let's copy the c column, it's 11 and 6. And let's copy the y column, that's 10, negative 5. Okay, determinant again is a times d minus b times c. A is 11, d is negative 5, b is 10, c is 6. Negative 55 minus 60 equals negative 115, and that is dx. Okay, now, I told you up here, x is equal to dx over d. dx is negative 115, d is negative 40. So at that point, you're just simplifying fractions. And if you know that 5 goes into both of those things, then you have, I'm sorry, I gotta think about how many times, 23 over 8. That is what x is. So on your main solution, you already have half of it done. Now you can do two things. You can either plug this back into this equation, these equations up here, to figure out what y is, which is my preference, or you can get the dy and then do dy over d. Okay, so So let's go ahead and do the dy just so you've seen one done that way in case you have to do that on your exam. So we solved for d, we solved for dx, now let's do dy. It doesn't matter which one you put first, it will turn out the same. So your constant column is 11 and 6, your x column is 2 and 3. Remember again, AD minus BC, 11 times 3 minus 2 times 6, 33 minus 12. Okay, so what you can do here is then back your way back into finding y. If you are lazy like me, and you just want to plug that x in up here, guys, you can solve for y that way as well, and that keeps you from having to do that whole third matrix, but that's completely up to you. Okay, we are moving on to number 7. Oh, not with that paper. Okay, number 7. Okay, if you can't tell, I'm glad matrices are over. Number 7 is asking you about the zero product property. Guys, that sounds complicated, but it's not. Let's talk real quick. Anything times 0 is 0. 0 times anything is 0. So when we know that, all we have to do is say, okay, if we know this times this equals 0, that means one of these two things equals 0. So either 2x minus 6 equals 0, or x plus 8 equals 0. It is that easy, okay? So add 6 to both sides. Subtract 8 from both sides. Okay? So that means you have two possibilities here. Do not use rounded brackets here. You've got to use your curly brackets because these are two different possibilities. Okay? If you do this, it is wrong. Do not do that when there's two different, these are an x and an x, not an x and a y. Okay? 7, that was the easiest question we have. 8 is also really, really easy. So all you're doing there, guys, is naming those points on those graphs. So 8 is find the points, find the intersections, sorry for my spelling, and name them. That's it. That is why on the third graph, there's no solution because they don't intersect anywhere. So 8's easy. Okay? Now, number 9. 9 is a quadratic, and they want you to use the square root method. So I bet you're going to have to square root something. So the equation, negative x minus 2 squared plus 16. First rule, all numbers go together. Okay? So let's get all the numbers on one side. Let's subtract. Okay? 9 minus 16 is negative 7. Okay, now this looks a little scary because you're like, Miss Wilmoth, I know I can't take the square root of a negative number. But you've got a negative on this side and a negative on this side. So we go through and divide by negative 1. And that cancels out that negative, cancels out that negative. So you end up with 7 equals x minus 2 quantity squared. Now I can square root both sides. And I get the square root of 7 plus or minus that equals x minus 2. Now all I have to do is add 2 to both sides, and I'm out of paper. So I get 2 plus or minus the square root of 7 equals x. And that is all she's looking for. Okay. Number 10, I'm sorry, is a multi-step question about stopping distance. So you're going to be using that same equation a couple times. I think there's just an A and a B. Yeah. So number 10. Okay, let me write the equation. D equals 0.048v squared plus 2.2v. Remember, v is velocity, d is distance. So it says if the car was traveling 50 miles per hour, so we're doing A, so it's the velocity is 50 miles per hour. Before the brakes were applied, find the distance. So we're looking for distance. Okay, so I'm going to plug in 50 for v. D equals 0.048 times 50 squared plus 2.2 times 50. This is nothing but a calculator problem. You don't have to even try. Just put that in your calculator. And your calculator will do the heavy lifting for you. And you'll get 230. Easy peasy. Letter B, a little different. Letter B, it says if the stopping distance is 390, what is the velocity? Not the same question. Okay, now we're going to plug in 390, but it's got to go in for D. Okay, now this is a quadratic formula question. So if you do not miss the quadratic formula, I am sorry, because what this looks like here's your A, here's your B, here's your C. Quadratic formula is opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so we're going to have to plug that in. Opposite of B, negative 2.2 plus or minus square root of B squared. Use your calculator, which is 4.84 minus 4 times A times C, which is negative 390. Okay, so then all of that over 2 times A, which is 0.048 again. Okay, work through that in the calculator. I'm not going to waste you guys' time with that. Be careful with your arithmetic. But to give you an answer so you are sure, you get 70.01, I believe, and it says to round to the nearest miles per hour, so 70 miles per hour. But make sure you can do this in the calculator. Alright, moving on to number 11. Okay, number 11 is talking about solving the equation. This is the same exact thing as a zero product property, guys. These are the easy questions. We pray for these on a test. Okay, negative 2x times x minus 3 times 2x plus 1 squared times x plus 4 to the third. Okay, all you have to do is set every piece equal to 0 because it tells you that it equals 0. X minus 3 equals 0. 2x plus 1 equals 0. X plus 4 equals 0. These are easy to solve. Divide by negative 2. X equals 0. X equals 3. Okay, And again, this is a solution set. All of these are x's, so do not use regular brackets. Make sure you're using your curly brackets. If you do this, even if your answers are right, this is wrong. Okay? Using curly brackets. Okay, number 12 starts rationals. Rational functions just have x on the bottom. That's all. Don't let it panic you, ever. They're actually pretty fun. So, number 12a says 2 over x minus 5 plus 1 equals 3 over x minus 5. Okay, y'all have been doing stuff like this longer than you know. Because when you have something on the bottom that you don't like, you just have to find a way to get rid of it. If it's divided by, then we need to multiply. So I'm going to take this whole equation, and I'm going to multiply it by x minus 5. And I can do that, as long as I do it equally to every term. So that means I have 2 times x minus 5 over x minus 5 plus 1 times x minus 5, because I got to do it equally to everything, equals 3 times x minus 5 over x minus 5. Now what? I've got some things that cancel out. Cancel out. Cancel out. 2 plus x minus 5 equals 3. Well, now this looks a lot easier. 2 plus x minus 5 equals 3. 2 minus 5 is negative 3 plus x equals 3. Add 3 to both sides. X equals 6. Easy as that. Now, letter B. Okay, so on letter B, you have negative 11 over 2x squared plus x minus 15. Sorry, I'm trying to copy off the original. Minus 2 over 2x minus 5 equals 1 over x plus 3. Now, anytime you see a rational with a trinomial on the bottom, it looks like this. They're trying to get you to unfoil this. Don't fall for the trap. Make sure if you see a trinomial, you want to unfoil that. That means get it back to those binomials. You want to factor it. Okay? Use the hints in the problem, guys. If they give you these bottom numbers, they're probably going to use those two factors to make this one. So, here's what I want to do. I want to unfoil or factor that bottom denominator. So I'm going to use 5 and 3, 2x and x, and I want to see if this works. 6x, 5x. I want the 6x to be positive, the 5x to be negative. These match these two. That's intentional, so that things can cancel, okay? It doesn't always work out perfectly like that, but a lot of times professors are nice. So use what you have in front of you as a hint. Now, what the heck do I do? I want to make these denominators go away. So I have to multiply by the one that's the most complicated, which is this guy right here. So I'm going to multiply every term by that denominator. Okay? So, negative 11 times 2x minus 5 times x plus 3 over 2x minus 5, x plus 3. Remember, I do this to every term. You can't skip one. I know it's a lot of writing. Now you get to do the fun part, which is canceling. Okay? 2x minus 5, 2x minus 5. X plus 3, x plus 3. I'm left with negative 11. 2x minus 5, 2x minus 5. That leaves me with 2 on the top times x plus 3 equals x plus 3 cancels. That leaves me with 1 times 2x minus 5. Alright, let's distribute. Negative 11 minus 2x minus 6 equals 2x minus 5. Combine these two terms, I've got a negative 11 and a negative 6, that's negative 17 minus 2x equals 2x minus 5. Let's get the x's on one side, so I'm going to subtract 2x from both sides. Negative 17 minus 4x equals negative 5. Okay, now I want to get the numbers on one side, so I'm going to add 17. Negative 4x equals 12. X equals negative 3. Okay. Now, here's something that you've got to go back and do. You're going back and checking if these things work, because if there is a place where you can divide by 0, then no solution. So, I'm going to challenge you guys to put that negative 3 back in for x up here in that original equation to see if there's actually a solution. When you plug negative 3 in, right here, do you see how negative 3 plus 3 would put a 0 on the bottom of the fraction? Guys, if there's a 0 on the bottom of the fraction, it's no solution, period. You don't have to worry about it. Okay? So, but you've got to double check, because if you submit your final answer as the solution is this is wrong. Because when you put it back in, it's undefined. Alright, we're going to go on to number 13. I'm running out of paper. Alright, number 13. Solve the equations 3 square root of 2x minus 1 and minus 3 equals 15. You must check your solution. Okay, these are fun. They are not hard. They are low stress. You just have to, they take a little bit of pencil work because you have to check your answers just like before. Okay, so I'm going to write the equation 3 square root 2x minus 1 minus 3 equals 15. Okay, square roots do not play nice with anybody else. You want to get him by himself. So the first thing I'm going to do, add that 3 to both sides. 3 times square root of 2x minus 1 equals 18. I want to get that 3 out of the way. I'm telling you, square roots don't play nice with anyone. So square root 2x minus 1 equals 6. Once that square root is by itself, you can get rid of it. But you can only get rid of it if it's by itself, and you get rid of it by squaring. So if I square a square root, then it goes away. So I have 2x minus 1 and 36. And then it's just as easy as it looks from there. 2x equals 37. X equals 37 over 2. Not a pretty answer, but it is a pretty question. Again, make sure you go back and you check that and make sure that it works. So you'll plug that value back in for x, but just for the interest of time, I'm not doing that because this video will be 80 hours long. I'm not solving the second equation, but it works the exact same. Do it the exact same way. Even though it's a cube root, you will just cube rather than square. Okay, number 14. Same general idea. Okay, I want to do the second equation so that I can show you what will happen when you run into these kinds of issues. So I'm going to do 4 equals negative absolute value x minus 5 absolute value minus 5. Okay, they're just like square roots. They don't like to be around other things. So let's go ahead and add the 5 to both sides. 9 equals an opposite square root x minus 5, or absolute value, sorry, x minus 5. going to go through and divide by negative 1 to get that negative 1 out of there. Negative 9 equals the absolute value of x minus 5. Guys, the absolute value makes all negatives go away. So no matter what number you put in here, you're never going to get a negative 9. So when you get to this point, if you see that an absolute value is all by itself, you've done everything you can to isolate it, and the answer is still negative, it's no solution. Easy, easy. Okay? So you can do the other one. The other one doesn't end up that way. I just wanted to show you those situations because you'll probably see one on your test. 15. G of x equals negative 3 square roots of x minus 2. Got a little crazy with my square root there. Plus 1. She's asking you for what happens and how is it different. Okay? Use the easy ones first. You know this n number up here, just like if you were going to have y equals 3x plus 1. That plus 1 would move that graph upwards 1 unit. It does the same thing down here. So it's going to shift up 1. It's going to shift. It's going to have a left and right shift. That's what this negative 2 does. Okay? But if it's under that house, then it's going backwards. So instead of going left like you would normally think, it's actually going to go right 2. This 3 is responsible for its height. So it's going to vertically stretch 3 times. And then this negative does its own thing. When it's negative, when that slope is negative up there, it's going to reflect across the x-axis. That is a fancy way of saying it's going to flip upside down. So just remember how these different numbers, that goes with that, that goes with that, 2 goes here, 1 goes here. Depending on where they're at in the equation, they're going to change these graphs differently. Last, but very not least, is number 16, and I don't have a lot of space. But here's the deal. This is a picture thing. Actually, I'm just going to go ahead and let's see. I'm going to show you the graph so we can talk about it. Okay. So, graph. It says, is it a function? Remember, each x can only have one y. So you're going to run your finger or run, whatever, if I had another piece of paper. I'm going to run that piece of paper across, and if it only hits my piece of paper one time, that's called the vertical line test. So it does pass that vertical line test. So it is a function. And increasing, all that means, does it go up or down, or does it not? Okay. Over here, it's constant, it's flat. Then the graph increases until it gets to 1, and then decreases to 5. So let's talk about how we write that and why. So, let's see if we can use this little bitty square of paper up here. Okay, so I'm looking at my graph. It is constant from, it's going off the paper to the left, so it's going to, we'll just say it starts at negative infinity, and it stops being constant at negative 3. Okay? Now, if you'll look at that circle at negative 3, it's open. That open circle means it doesn't include it, so I use a round parentheses. But then at negative 3, if you'll look down here, this got a closed circle right here, so it's included. Included is where the square bracket came from. So from negative 3 all the way up to 1, it is actually increasing. The graph is traveling in an upward direction, going up. It is decreasing from 1 all the way to 5. And that circle is closed, so we're going to use a square bracket rather than a curved one. Okay, that is as complicated as that gets, but those are easy questions to ask, so make sure you understand. You're just talking, these are not XY ordered pairs, they're only talking about the X. So from negative infinity all the way to negative 3, we're just looking at left and right. And that is your whole review.